Hi guys, for today's lesson we're going to be dealing with expanding perfect squares and the difference of two squares. So first up, what do I mean by this term a perfect square? Well, it's a binomial which has been squared. So for example, we've got a perfect square right here. Inside the bracket we've got a binomial and it's been all squared. We say this is x plus 4 all squared. Next up, what do I mean by a difference of two squares? So it's a binomial that consists of two square numbers that are subtracting. So for example, this expression right here, we've got x squared and 9, which are being subtracted from each other. This is a difference of two squares. So like x squared we consider to be like a square number, and 9 is also a square number. The reason is we can perfectly square root these things to get like a like nothing with like a decimal or a surd, etc. Another example is like this: 25 is a perfect square, 16y squared is a perfect square, and there's a subtraction between them. So yeah, that's what we mean by a difference of two squares, these sorts of situations. Okay, so some rules to remember. When expanding perfect squares, we can apply FOIL. So for example, I want to be able to expand this sort of expression here. So x minus 4 all squared. Well, the idea is we can change this to this. Like this expression is pretty much saying that we've got x take away 4 and it's being multiplied by itself. So that's exactly what happens here. X minus 4 multiplied by itself. When we expand these brackets using FOIL, like these are the firsts, x, and x, and then we've got outsides, x and minus 4 to make minus 4x. Then we've got again the insides, x and minus 4 again to make minus 4x, and plus 16. And we end up getting this. So we end up getting this sort of expression. You can see here that this middle term, because it's a perfect square, these two middle terms these two middles, like the outsides and insides of FOIL, they're going to end up being the same. So that's why it becomes our minus 8x in this case. Note, a quicker method involves remembering the following saying. So we say square the first term in this case. So square the first term, twice the product of the two terms inside the brackets, and then lastly square the last term. So this is a nice quick way to do it. So for example, let's try this nice quick way with this example here. So this is our expression that we're trying to expand. We can see this is our first term and this is our second term. Make sure that minus is going with the second term. It's a negative 10, and we can apply this sort of strategy, this quick strategy here to this sort of question. So square the first term is pretty much meaning that we want to square 3x, so that's what we've done here. We want to twice the product of the two terms. So we want to multiply these two terms together and then double it. So you can see here 3x is times by negative 10 and it's being doubled times by 2. And then lastly, you need to square the last term. So square negative 10, as you can see here. And we just need to simplify this sort of thing. So 3x all squared is going to be equal to 9x squared. Tick, done. Next up, this simplifies to negative 60x. And lastly, this simplifies to 100. So we end up getting this sort of expression, which is equivalent to this original perfect square. When we are expanding two identical binomials which have opposite signs between the terms, you'll always receive a difference of two squares for your answer. So for example, have a look at this. This is the sort of situation which we want to be able to expand nice and quickly. So our brackets are identical, but one has a plus between the terms and the other has a minus. So when you're in this sort of situation, it is not a perfect square because these brackets are not exactly identical. We can apply FOIL to do this. So if we apply FOIL, we get our first will make 25x squared. Our outsides will make minus 20x, and the insides will make positive 20x, and the last will make negative 16. You'll notice when you've got this sort of situation of identical brackets but one plus and one minus, you'll get these middle terms cancelling each other out. So you'll just be left with these two outside parts as your final answer. And this is what we call a difference of two squares. Both of these things we've got by pretty much multiplying something by itself. And we can see that the +4 and the -4 are going to make a negative number here. So that's why it's a difference of two squares. Note, a quick method for expanding these sorts of binomial products is this sort of saying right here. So we can square the first term, square the second term, and then subtract in between. So if we want to say expand this using this sort of saying here, we can square the first term. So 4x is our first term and plus 3y is our second term, which is the case for both brackets, except instead of positive it's negative, which won't end up making a difference. So following the sort of saying that we've got here, square the first term, so square 4x, square the second term over here, so square 3y, and then subtract in the middle. So this simplifies to 16x squared, this simplifies to 9y squared, and that minus comes down in between. So this expression here is equivalent to this expression here. This is in expanded form. There's no brackets there. Hope this helps with the questions, guys. Good luck.